Hi, I'm Earl from the National Institute of Mental Health Data Science and Sharing team. I'm also a BIDS maintainer, so talk to me later if you'd like to learn more about that. I'm honored to have been chosen to give a software demo today about my topic, BIDS tabular phenotype data software for big neuroimaging studies. It's also poster number 2464 up in poster session 3 right now, and I'll be with it tomorrow in poster session 4 as well. I once heard someone say, BIDS is like the keto diet or CrossFit because everyone who does it won't stop talking about it. Today, I'm talking to you about a BIDS software tool that will change your workflow for big neuroimaging tabular phenotype data. And with that in mind, I want to give you the punchline of the presentation real quick. If you're going to forget everything else from this presentation, you can take a picture here and remember this. Our software is fair principled, and it does the hard work of BIDS standardizing big neuroimaging tabular phenotype data. And you can download some data in dictionaries right now. In other words, we have software now that standardizes tabular phenotype data to BIDS for big neuroimaging studies, and it's free and open source. If you're at all like me when I started this project, you might be asking yourself, what is tabular phenotype data? And what does big neuroimaging mean? I'm about to talk about that briefly, and then we'll talk about what I mean by converting big tabular phenotype data to BIDS. Then I want to demo this software so you can see how to do it yourself. Okay, so raise your hand if you are very confident on the answer to the question, what is tabular phenotype data? I'll give anyone who's right a piece of candy at my poster using the honor system. The definition of a phenotype is broadly about observable characteristics of an individual's interaction with their environment. That could be everything from how you hold your mug to how you respond to an IQ test. Then tabular means the data is organized into columns and tables. So put together, we're talking about tables of data that represent observable characteristics of individuals, like this maybe familiar looking example to the right of random tabular phenotype data. BIDS covers imaging phenotype data pretty well, but the tabular phenotype data is what still needs work. Where might you find tabular phenotype data in the wild? It comes from many sources you probably already know of, like assessments, forums, instruments, labs, questionnaires, and surveys. At least that's what I consider tabular phenotype data. So let's move on to what is big neuroimaging. I think big neuroimaging is not only studies which have a large volume of data points, but studies which are widely used. These are just 6 of the many awesome studies out there that have been curated and shared widely that we should all be grateful for. Our goal in this project is to provide end users of data sets with BIDS standardized versions of their tabular phenotype data. And while that sounds easy, it's actually a non-trivial problem. We can't fill out the data use agreements for you, and we can't download and store most of the data itself for you either. So instead, we provide data in dictionaries as possible and a documentation website for the repeatable steps. So anyone can do that and track exactly what happened and when, and create those files themselves. So some studies also began before BIDS was born, and others haven't been able to release BIDS versions yet. So it's understandable they're not all already BIDS. I'm about to show you some notable facts about how the tabular phenotype data come when they're downloaded from these studies' curators. So for the ABCD study release 4, there's more than 350 pairs of tab separated value phenotype data, and they're comma separated value data dictionaries. For the Healthy Brain Network, there's over 120 pairs of comma separated value phenotype data, and they're Excel format data dictionaries. For every study, something is just a bit different among how many phenotype files there are, or what format the data or dictionaries are in. And I mentioned data dictionaries a few times now, but I haven't defined it. So let's rewind for a moment to re-ask the question, what's a data dictionary? Data dictionaries hold information about the data, like its meaning, how it relates to other data, where it came from, and more. For instance, in the example I showed before, you may have asked yourself, how exactly is race defined, or what are these coded education values supposed to mean? Which brings me to the next section about how we convert tabular phenotype data to BIDS. In BIDS, for every measurement tool containing tabular phenotype data, you need to have the data in a tab-separated value file and the dictionary in a JavaScript object notation or JSON sidecar file. There's about 5 rules for TSV tabular data and 5 possible descriptors for JSON dictionary fields. But put together, they're a cohesive pair and they support each other well. So let's take one more step back and recognize BIDS is not the only one trying to standardize tabular phenotype data. So I want to at least mention a few other great efforts put forth in our community to prove to you this is not a trivial task. There's the neuroimaging data model, or NIDM, which defines extensions to the W3C provenance standard for neuroimaging files. And there's CiteDS, which is inspired by BIDS and is guided by the principles of files being both human and machine readable and being privacy aware from the start. There's also NeuroBagel, which is built to harmonize neuroimaging data sets for federated search, amalgamation, and analysis, as well as allowing user annotation. So given these ongoing efforts, last year at OHBM, my colleague Sam Gway presented our poster on BIDS Phenotypic Data Guidelines, also known as BEP 36. BEP 36, which is a work in progress that you can contribute to right now if you want, offers 3 options to curate BIDS tabular phenotype data and provides examples and tools to do so. So you can see there's a wealth of people working on this, but it's still not culminated in one universal standard yet. So if we go back to BIDS now, the good news is we've solved these BIDS conversions for you with our software. This repository's command line interface, BIDS Phenotype, is pip installable and takes a minimum of arguments, produces the requested data or dictionaries or both. So I pre-recorded a demo that starts out with me creating a virtual environment in Python 3.8, and then I activate that environment. You'll see how it doesn't have any Python packages installed yet. So I'll install BIDS phenotype data after I point that out with pip freeze. See, nothing. And that pip install takes about 10 seconds or so. So as soon as it's done, I output the command line interface's help. Notice how the command looks in the help text. There's going to be 3 positional arguments and 4 optional arguments. One of those optional arguments is help. So it's really just data set, input, and output for the positional, and data dictionary are both for the optional. At the input, first let's note the input and output folders I have. There's HCP 1200 and PNC in the input right now, and the output's empty. So we're going to start with PNC, and you see how it says BIDS phenotype, then PNC. PNC is the data set. Input/PNC, that's the input path, and that's going to be where we have our input data and anything in a flat folder structure as their original names and formats. And the output folder is where the phenotype file goes, like you can see there for output PNC. Then we're going to do it one more time just to prove that was the dictionary for PNC. This one, we're going to do both the data and the dictionary for HCP 1200. So you can see I'll type --all. I could have typed --both for doing both the data and the dictionary. And then we'll look at the output, and you can see it's got both the data and dictionaries we created for both the restricted and unrestricted tabular phenotypes. All right, so in closing, I hope you've learned these things today. Standardizing data is hard and requires non-trivial design decisions throughout to conform to BIDS. That work is done with our software, and it's findable, accessible, interoperable, and reusable. So you can go to the repository and look at some data and dictionaries yourself right now. And anyone with a GitHub account can make new requests, report things to improve, or even help out with some improvements themselves. And there's the GitHub URL for the repository as well. With that, I would like to thank my fabulous open science collaborators on this project so far, and a special thanks to Adam Thomas, who has believed in me from the start, helped guide this project. And I'll leave you with a joke from my daughter because I promised them I would present it, and it's pretty funny. Why did the bug not want to share his data? Because it was buggy. Thank you, Martha. All right, so with that, here are my references and links at this QR code on Linktree. And remember, the poster is 2464, so stop by at OHBM and come see me. Thanks for watching.